Welcome. We are now going to practice writing the first step of hypothesis testing, which would be to write the hypotheses. So we'll have two hypotheses, the null hypothesis and the alternative hypothesis. And some type of claim is going to be made about a population parameter, and that is what we will be testing. So when we read our problems, we're going to be looking for claims that involve a less than, a greater than, or a not equal to. Claims can also contain one of these other symbols. However, we restrict in our class, we're going to just stick with those first three possibilities. So in doing so, the alternative hypothesis, which has to have one of those three symbols, means that for us, our claim will always be the alternative. So as I move forward, you're going to see that I always write the alternative hypothesis first, and then we'll get back to this other stuff in just a bit. All right, directions. So for each conjecture, state the hypotheses, identify the claim, indicate the direction of the test that would be used to test the claim. So let's jump in here. So what we're going to do is just change the English first into symbols. So a manufacturer claims that the mean time to complete the assembly of one of their toys is less than 15 minutes. So remember, we're looking for a less, a greater, or a not equal to, and that says less. So far here, we are in good shape. So the parameter that they are investigating or stating a claim about is the mean. Now remember that we're always trying to draw conclusions about the population. So they're claiming that if everybody in the world tried to assemble this toy, that population mean would be, so mean would be less than 15 minutes. So less than is the less than sign. And that will be our claim. So mu, population mean, is less than 15 minutes. All right, the null hypothesis, not the claim, the null hypothesis is always going to be a statement of equality, so that the mean is 15 minutes. So the way hypothesis testing works is if somebody's making a claim, then it's up to them to conduct their research, collect some sample data, and try to convince us that their claim is supported by the data. So the manufacturer will go out and run a study, have a sample of people put the toy together, and find the sample mean, so that's X bar. And if that sample mean is significantly smaller than 15, then we're going to say I reject the null hypothesis and conclude I've got evidence to support that claim. So when we say sample mean needs to be significantly less than 15, we will define significantly in detail coming up. You can just think of it as much less. So much less than 15. It will lead us to support our belief, the manufacturer's belief. All right, so if you think of a number line, numbers smaller than 15 would be to the left of 15. And that's why we call it a left tail test. So that's the direction. Okay, and then later we move forward and actually collect data and investigate. So again, right now we're just practicing writing hypotheses. So let's look at number 2. Restaurant claims that the mean time, that the mean time it takes to prepare one of their signature entrees is greater than 30 minutes. All right, so we're still dealing with the population parameter mu for mean, and now we have is greater, so that's the greater than sign. And our claim will always be our alternative hypothesis. So this is that the mean is greater than 30 minutes. The null hypothesis will always be equal. And the direction of the test. So if the restaurant is going to investigate, they're going to have to go get some sample data. So they go out and they sample some of the times making their signature dish, and their sample mean they want to convince us that the mean is greater than 30 minutes, then they better get a sample mean significantly greater than 45 minutes. Well, that's a typo. I will fix that later. 30. So if we take a sample and find the sample mean to be significantly greater than 30 minutes, then we will reject the null hypothesis and support that claim. All right, so think of a number line. If you had 30, numbers bigger than 30 are to the right of 30, and that's why we call it a right tail test. Okay, so before I keep going here, in hypothesis testing, you assume the null hypothesis is true, and then you gather evidence to see if it supports your claim. So this is what we're talking about right now. So we have a claim, and we're either going to decide to reject the null hypothesis or not to reject it. So I'm just using the phrasing now. Let's say we do reject it, and that means we would support the claim. So rejecting the null supports the claim. If we did not reject the null hypothesis, if we were unable to reject this, then we would be unable to support our claim. And we will practice that all coming up. All right, but let's just keep practicing writing hypotheses. All right, so number 3, the mean height of a certain type of plant is 20 centimeters. A researcher speculates that the mean height differs for plants exposed to a certain pesticide. All right, so parameter mu for mean, and then differs for plants exposed to a certain pesticide. All right, so in this case, population mean, and then differs. So they're not saying they think it's greater or smaller. They just think it's going to be different than 20. So that would be our not equal to. All right, so our claim is that the mean will be different than 20 centimeters. And the null hypothesis, always the same mu parameter and always equality. All right, so if a study is done and they would like to see some evidence, the researcher wants to see evidence that the mean isn't 20, well, evidence that would support that would be values significantly bigger or possibly significantly smaller. So in either case, bigger or smaller, that's where the evidence would lie. So that's why we call this one a two-tail test. So numbers to the right or left of 20. Two left, sorry. You can tell I'm tired here. There we go. Two-tail test, two-tail test. All right, and that's because it's a not equal to. Okay, so before I keep going here, a left tail test and a right tail test, those would each be called one tail tests. And then, of course, two tail tests. All right, so now let's just practice a few more and we will wrap up this practice. So number 4, the mean height of a certain type of plant is 20 centimeters, but a researcher believes that the mean height is greater for plants grown with a particular nutrient. So you'll see why I'm focusing on doing the claim first as we start reading problems that are a little more involved with information. All right, so the claim is that the mean and is greater than 20 centimeters. The null hypothesis always gets equal. And if it's a greater, then that makes it a right tail test. All right, number 5. Last year, the mean price of a certain item purchased online was $49.25. A researcher claims that the mean price has changed this year. All right, so the claim, the mean, so has changed is another way of saying that it's now different. So not specifying if the researcher thinks it's higher or lower, just that it's different. So has changed is another way of saying not equal to. So the mean is not 49.25. $49.25. Null hypothesis is an equal 49.25. Because it's a not equal to, that makes it a two-tailed test. All right, one more. A coffee dispensing machine was designed to dispense a mean of 8 ounces of coffee per cup. We wish to test the claim that the true population mean is actually less than this. All right, so the mean. Now I put here true population mean. We really didn't have to say true population mean because anytime we're doing a hypothesis test, it's always a population parameter. So the mean is less than 8 ounces. The null hypothesis gets an equality equal to 8 ounces. And because that's a less, it makes it a left tail test. All right, so there you go. Some practice writing hypotheses. And then as we move forward, our claim will be that alternative hypothesis, and we'll be gathering data to see if we will be rejecting it, which leads us to support our claim, or not rejecting it, which would lead us to not support our claim.